Hello, am I audible?
Yes,
Okay. Okay, we'll start in a couple of minutes. Okay. Okay, welcome to week 5 of this problem solving session of this course optimization methods. So, in this today's lecture, we will be seeing through the contents that have been taught in the week 5, that is quadratic approximation and then constraint optimization, like multivariate constraint optimization with equality constraints. So, we'll just brush up the concepts once and then we'll proceed to solving some numericals. So what are the what is quadratic approximation method? So this is this is a method for solving a multivariable or a single variable optimization problem by converting it to a by approximating the polynomial function into as a quadratic expression, and this quadratic expression can be derived by using the Taylor series. So for example, if fx is given like this, suppose it's a fourth order polynomial, x to the power 4 plus 3x cube plus 2x cube plus 5x plus 7. We'll write this fx in we'll expand this in terms of Taylor series up to two terms. So it will be f of x naught. We will be assuming the initial solution of this initial minima or optima of this function as something x naught, and we will expand the function about x naught. So it will be f of x naught plus x minus x naught into f dash x naught plus x minus x naught whole square into f double dash of x naught. So we'll be proceeding only till two terms, so till the second order derivative term. So x naught is the initial approximation of the solution, that is the initial minima what we are assuming. So now we will have to proceed in such a way such that we obtain the desired minima or the optima of the maxima or the of the function, that we will denote this as x star. And x star will be a minima for fx if f of x star is minimum and f dash of x star is equal to 0. Now suppose if we have suppose seventh order, eighth order, very like higher order polynomial. Now finding f dash x star equal to 0, it will be something a sixth order polynomial. And to get the solution of a sixth order polynomial by simple algebraic calculation is not easy. So we have to use numerical approximations to get the value of this function. That is, if f dash x star is greater than a like third order or fourth order polynomial. So how do we proceed? We will proceed. So we have assumed that f of x equal to f of x naught plus this term. So f of x will be minimum if the second term, that is x minus x naught f dash x naught plus x minus x naught x minus x naught whole square in f double dash x naught. So this value is minimum. If this is minimum, then f of x will have the minimum value at x star. Now the steps are, assume first we assume some value of x naught, then we minimize the function x minus x naught, this f dash x naught plus x minus x naught square f double dash x naught, and then using Newton's method or conjugate direction method, you can do the minimization because now it will be converted to a a single variable problem. It is not that to multivariable or a higher order polynomial. We will have only the function that we're minimizing, it will be only a second order, that is a quadratic polynomial. it will be a quadratic polynomial, and we can minimize a quadratic polynomial simply by Newton's method in one step. That is, we have seen that we can get the solution x, if x star is the solution, then x star equal to x naught minus f dash x naught by f double dash x naught. So in only one step only we can get the solution. See, we can also apply the Newton's method directly to the whole expression also, but in this case we'll have to apply Newton's method multiple times. There will be many number of iterations. But when we are doing it by a quadratic approximation, we can do it only in one step. That is, you can get the minimization of the quadratic polynomial in only one step of the Newton's method. So it becomes, the calculation becomes a bit easier. So we'll proceed with the iteration, and we will iterate till we get f dash of x star is very near to 0. We won't get exactly equal to 0 because it is difficult to get it by using numerical methods. So we'll be setting some epsilon value. That is, the epsilon is the uh, threshold or limit, and if f dash x star is less than this epsilon, then we'll say that this is the x star is the value where the function will have the minima, and if we can calculate f of x at that value of x star, we will say that this is the minimum value of the function. So this will be very near to 0, something like 0.002 or 0.001. You can set something like that based on our requirement. So we'll solve the problem, but before solving, we'll just see through what is constraint optimization with equality constraint. So a constraint multivariable problem in standard form is written in this format. That is, we have to minimize or maximize the function of f of x1, x2, which is given subject to the condition that g of x1, x2 is equal to 0. So this is a graphical representation of the function. So the red contour line shows the variation of the function f of x1, x2, and the g of x1, x2 is the constraint. This is a line representing a constraint. So I think the derivation has been done in class. But from derivation, we get that d of x2 is equal to minus of del g by del x1 divided by minus del g by del x2 into d of x1. So this comes by getting g of x1 star plus dx1 x2 equal to 0, and we can expand as Taylor series. We are assuming some value x1 x2 star at some point, and we have to see that even if we increase the value of x1 by dx1 and x2 by dx2, then also the constraint should meet the condition that it has to follow this condition always. So if we expand this, then we will get this condition. So I'm now putting this value of dx2 in the total derivative of the objective function. We'll get d of f equal to dl f by del x1 into dx1 minus of del f by del x2 into del z by del x1 divided by del z by del x2 into dx1. We can rearrange the terms and we can put it in this form. So this is called the necessary condition for optimality for optimization problem with equality constants. This is called multivariable optimization. Now, when we come to constraint optimization, so we have got a necessary condition. Now there is a method called Lagrange multipliers, which is used for solving this constraint optimization problems. So what we do here, we assume that we define this term that del f by del x2 divided by del g by del x2 is and into minus of this one as lambda. This lambda is called the Lagrange multiplier. So if we replace the value of lambda in this equation, we'll get the equation in this format: del f by del x1 plus lambda and del g by del x1 equal to 0, which can also write, if we assume that instead of x2 you are taking x1, that is, we are taking the ratio as, for this condition, lambda equal to minus of, so so del g by del x1. So we can either assume that the lambda is the ratio of del f by del x1 by del g by del x1, or it will be the ratio of del f by del x2 or del g by del x2. We can assume either of these two. So if we assume one of these, we can then proceed with the solution. So we'll have two equations. One is this equation, and the second is the g of x1 x2 equal to 0, and this comes by del by del lambda equal to 0. Now, okay, so what is the method for solving this multivariate optimization problem using Lagrange multipliers? So this is the problem formulation. This is a problem with n variables and m constraints, n equations and m constants. So we will proceed. That we'll write the Lagrange function as this one: L of x1 x2 n. L is a function of x and lambda. It will be f of x plus lambda 1 g of x1 plus lambda 2 g of x2 up to lambda m into gm of xn. Now we will have to satisfy the conditions. How? We'll take the derivative of this equation with respect to each of the variables. So del L by del xi, and xi goes from I is equal to 1 to n. For all the n variables, we'll take the derivative to get the minima, that is a condition for minima. And secondly, we also have to take the derivative of L with respect to lambda. If there are m lambda, because the number of lambda will be the number of constants. So lambda I is equal to 1, 2. So now, if there might be two conditions. One is the lambda value is very small; it might be very near to 0, or it is exactly equal to 0. In that case, the constraint will not be significant. But if the lambda is large, then the constraint needs to be handled very carefully. That is, we have to solve it properly. Okay. So in that case, constraint is significant. Okay, this is about Lagrange multipliers. We will see through the problems now. If you have any doubts in the process, you can ask me. Okay, then we'll proceed with the problems. Let us solve the problems one by one. The first problem: the quadratic approximation of f of x is equal to e to the power x plus x square at x not equal to 0. Now we have to do this for only one iteration, because x not equal to 0 is given. We have to do only for the first iteration. So we'll write f of x in terms of f of x naught. Now to calculate f dash and f double dash, we'll write the formulation of the first derivative and the second derivative. F dash x is given as it will be we are using a chain rule here, so it will be 2x plus 1 into to the power x square. F double dash x will be, so we'll have to do the differentiation by parts, so we'll be differentiating one by one. So first there will be 2x plus 1, we will take the differentiation of this. So it will be 2 will be there. So differentiation of e to the power x plus x square by dx is again is what we got in the first term. So it is 2x plus 1 into e to the power x plus x square plus 2 into e. So we can take e to the power x plus x square common, 2x. Okay. So we got f dash x and f double dash x. We can substitute, get the value of this at x equal to x naught. So f dash x naught, if we put 0, it will be this into 0 0, 1 into e to the power 0 is 1, and f double dash x naught, it will be 0 plus 1, 1 plus 1 2, it will 3, 3 into e to the power x plus sorry, this will be 1. So now we'll expand the f of x as quadratic expression, and also f of x naught will be how much? 1. F of x naught is equal to 1 only, so it will be 1 plus x minus 0 is x into f dash x is 1 plus x square into, so I think it's, yeah, oh sorry, this is one mistake, this is by 2 will be coming because we are taking a Taylor series, so it will be 3 by 2 x square. This comes from Taylor series only, so it will be x minus x naught whole square by 2 into f double dash of x. Okay, so the correct answer is 1 plus x plus 3 by 2 x square. I hope this is clear. This is just, I'm going to take a differentiation and do the quadratic approximation of the function only at the first function value. Okay, let's proceed to the next question. Okay, find the minimum value of f of x y equal to x square plus y square subject to the constant 2x plus 4y equal to 15 using the method of Lagrange multipliers and evaluate. lambda. So how will we g of 2x plus 4y? We will write g of xy in terms of in as g of xy equal to 0 in terms like we'll bring 15 to the left hand side and write the equation in this format. Now we will write the Lagrange equation. What is the Lagrange equation? The Lagrange equation is the this one, f of x plus lambda 1 into g1 of x. So y squared plus lambda into 2x plus. Okay. Now I have to take the differentiate lambda with respect to x, or differentiate L with respect to x, with respect to y, and with respect to lambda, because it is a function of three variables, and we have to see that the differentiation is equal to 0, so that we'll get the for minima for all the three variables. So del L by del x is equal to 2x plus 2 lambda equal to 0. For lambda equal to 0. Del L by del lambda is equal to 2x plus 4y. Or here, from here we can get lambda is equal to x. From here we can get y is equal to minus right. Y is equal to minus 2 lambda. So now we can substitute x and y in terms of lambda here. So it is equal to 2 into minus lambda plus 4 into minus 2 lambda. 2 plus it is equal to 10 lambda is equal to minus 15, lambda is equal to minus 3 by 2. Did I do some mistake? Mm, I think they are assuming this as different one. We can also write this equation in these terms, right? So if you write the constraint equation in terms of this as the negativity constraint, that is like we are taking the x and y terms to the right hand side, we can write the equation in these terms. In this case, we will what we will get. So this will be minus lambda. So minus lambda. So it will be plus x plus 2 lambda. So it will be plus plus. So while lambda is equal to plus 3.2 1.5. Now if we to substitute, we know lambda, so x is equals to 1.5, y is equals to 3. So the function value is this 9 plus 11.25. The thing is that lambda value we are assuming for this function it don't matter because it is a quadratic. This is a quadratic function, is x square plus y square. Even if lambda x and y are negative, we will have the same value. So that's why lambda value won't be mattering. But for the sake of the question, we are getting it, writing the constraint in this format. Okay, so we'll be proceeding with this standard method only. That we will be writing the constraint. That is, we'll take the variables to the right hand side. So let's proceed to the next question. What is given? We have to minimize the function x1 plus x2 plus x3 square subject to x1 equal to 1 and x1 square plus x2 square equal to 1. So our f of x1 comma x2 comma x3 is given as x1 plus x2 plus x3 square. Now g of, we'll write one constant as g of x1 comma equal to 0, and the next is g of, no, it will not write g, we'll write some other terms, maybe we'll write as g2. G2 of x2, I think this is function of x2 and x1. 1 minus x1 square minus x2 square equal to 0. So these are the constraints, right? Okay, so we write the Lagrange form. So we write the Lagrangian. So L is equals to f of x1 comma x2 comma x3 plus lambda 1 into g1 of x1 plus lambda 2 into g2 of x1 comma x2. So based on a number of, if there are an n number of constants, we will have n number of lambdas. So number of lambda is equal to number of constants. So we'll write the expand the form. It will be x1 plus plus x3 square plus lambda 1 into 1 minus x1 plus lambda 2 into 1 minus x1 square. So we can take x1 common from here. So it will be 1 minus lambda 1 into x1. I think I don't think we'll take any other common. So it is again off from it is 2 minus lambda 2 into x1 square plus x2 minus lambda 2 into x2 square plus x3 square plus lambda 1 plus lambda 2. So this is the Lagrangian that we are getting, and I think this is the correct option. Now we can solve this. We can have to take the differentiation with respect to all the four terms. It is not given the question to solve the Lagrangian. We will solve it. So it will be del first condition to get the necessary conditions. First del L by del x1 is equal to 0. So it will be 1 minus lambda 1 s of 2x1 lambda 2 is equal to 0. Del L by del x2 minus lambda 2 into 2x2 plus 1. Del L by del x3 is equal to 2x3 is equal to 0. Del L by del lambda 1 x1 is equal to 1. Del L by del L2 x1 square plus x2 square is equal to 1. From here we'll get x1 is equal to 1. So x2 is equal to 0. x3 is equal to 0. From here we will get 1 minus lambda 1 minus of 2 lambda 2 is equal to 0. And from here if x2 is equal to 0, lambda 2 can take any value. So if lambda 2 can take any value, so we'll have to put lambda 1 is equal to 2 lambda 2 minus 1. So lambda 2 and lambda 1 are dependent, and in this case lambda 2 can take infinite number of values. We can also take lambda 1 as proportional to this lambda 2. So this will have infinite number of solutions. Okay. Any doubts till now? Okay, and if there are no doubts, we will proceed to the next problem. Determine the optimum location of the following constant. Location means you have to find the value of x1, x2, x3 subject to this constraint. So we'll have to solve using this Lagrange function only. So let us write. So let us write the equations. So the Lagrangian will be f of x plus lambda 1 g1 of x plus lambda 2 into g2 of x. So we have rewrite f of x equal to what? So 1 square plus x2 square square plus lambda 1 g1 of x will be how much? x1 plus x2 plus 3x3 minus 2. So we will write it, take it to the right hand side and write it 2 3x3 plus lambda 2 into 5 minus 5x1 minus 2x2 minus x3. Okay, so we've got the Lagrangian. We'll take the derivatives now. Del L by del x1 will be what? 2x1 minus lambda 1 from here. So 2x1 is coming from here minus lambda 1 is coming from here, and from here it will, how much will come? Minus 5 lambda 2. Okay, I think no more lambda 1 or x1. Say similarly del L by del x2. So from the first term, this is coming 2x2. From the second term, it will be minus lambda will be coming here, minus lambda 1, and from the third term, it will be minus 2 lambda 2. Next, the third term del L by del x3. So it will be 2x3 minus of 3 lambda 1 from second term minus of lambda 2. Okay. So we have the three terms. Now next, the constraints will come del L by del lambda 1. So it will give del by del lambda 1. This is for lambda 1. This is for lambda 2. x1 plus x was 3x3 minus 2 is equal to 0. So the second constant will come 5x1 plus 2x2 plus x3 is equal to 5. Okay, so there are 5 variables and 5 equations. So how do we solve these equations? We can solve the linear equations one by one. So let us write everything in terms of x1, x2 and x3 in terms of lambda 1 and lambda 2. So once we get in terms of lambda 1 lambda 2, we will substitute in the fourth and fifth equation. So we'll get from here x1 is equals to lambda 1 plus 5 lambda 2 divided by 2 from here x2 is equals to lambda 1 plus 2 lambda 2 by 2, and from here x3 is equals to 3 lambda 1 plus lambda 2 divided by 2. So we have got x1, x2, x3 in terms of lambda 1, lambda 2. We'll substitute here in these two equations. So let us write x1 is lambda 1 plus 5 lambda 2, and x2 is lambda 1 plus 2 lambda 2, 2 into, and lambda x3 is 3 lambda 1 plus lambda 2. And these all are divisible by 2, then denominator is 2. I am taking the 2 into right hand side. So 2 into 2 is equal to will be equal to 4. So we'll rearrange the terms. So lambda 1 plus 6 lambda 1, it will be 8 lambda 1 plus 5 plus 2 7, 7 plus 2 8, 9. 9 lambda 2 is equals to 4, and equation number 5 implies is equal to 5 into lambda 1 plus 5 lambda 2 plus 2 into lambda 1 plus 2 lambda 2, and x3 is 3 lambda 1 plus lambda 2 is equals to 10. I'm taking denominator to the right hand side, so it will be, so 5 plus 2 7, 7 plus 3 10, 10 lambda 1 plus 25 plus 4 29 plus 1 30. Lambda 1 is equals to 1 minus 3 lambda 2. So substitute in 6. So what we will get is equal to 8 into 1 minus 3 lambda 2 plus 9 lambda 2 is equals to 4. So what are we getting? So it will be 8, 4 minus 8 is minus 2, minus 24 plus 9. I think lambda 2 will be equals to 4 by 15, right? So lambda 1 is equals to 1 minus 4 by 5, so 1 by 5. So lambda 1 is 1 by 5, and lambda 2 is 4 by 15. So we can substitute in these 1, 2, and 3, and these three equations to get the value of x1, x2, and x3. So let us see what values we get. This is a simple calculation only. So x1 is equals to how much? Lambda 1 plus 5 lambda 2 by 2. So lambda 1 is 1 by 5 plus 5 lambda 2, it will be 4 by 3 by 3 plus, so 23 by 30 is how much? 0.76 discount something. I think it is approximately something 0.8. Similarly, x2 will come approximately this one 0.34, and x3 will be approximately 0.28. You can do the calculations later. I am not doing a detailed calculations. I have shown the method. I hope the method is clear how you solve using Lagrange multipliers. Okay, if there are any doubts, you can ask me in the process. I will proceed to the next question otherwise. Okay, if there are no doubts, we will proceed to the next question. So this is again a question of what is the approximation. We again have to approximate the value at x not equals to 0. So we'll write f of x in terms of f of x naught. So we'll have to calculate f of x and f dash of x. F dash of x is how much? First, let us write f of x. F of x equal to e to the power x sin x. So f dash of x will come as what? So e to the power x d by dx into sin x plus sin x into. So differentiation of sin x is cos x. So cos x into e to the power x plus sin x into differentiation of e to the power x is e to the power x. So it is equal to cos x plus sin x into e to the power x. Now f double dash x. So differentiate this once again. So again it will be e to the power x into differentiation of this one. Differentiation of cos x is minus sin x plus differentiation of cos sin x is cos x, and plus cos x plus sin x into differentiation of e to the power x is e to the power x. So we can take e to the power x common, so it will be sin x and sin x will get cancelled, so it will be 2 into cos x. Okay, so at x equal to 0 we will have to estimate x naught is equal to 0. F of x naught is e to the power x sin x, so sin 0 is 0, so it is 0. F dash of x naught is equals to sin 0 is 0, cos 0 is 1, e to the power 0 is 1, so it will be 1 into 1 equal to 1. F double dash x naught is equal to cos 0 is 1, e to the power 0 is 1, so it will be 2. So therefore we can write f of x equals to f of x naught 0, 0 plus x into 1 plus x squared into square by 2 into. So it will be x plus x squared. The answer is x plus. How you solve using quadratic approximation? Now, if we have to do the for further steps, what we do? We minimize this function. You minimize this function and you get by using the Newton's method, or you can also use uh, conjugate gradient method. We can use any of the methods and then proceed to the next step. So we will be solving one question in detail regarding what the approximation. So it is these questions are based on that one. Okay. So for the next questions, I hope you can see the screen. It might be slightly small. I hope you can see the screen properly. Yeah. So this is a multivariate function. It's not a single variate. So for a coordinate approximation of the function f of xy is equal to sine of x into cos of y at point xy equal to pi by 3 and pi by 6. You have to give one point is given. The initial point is pi by 3 comma pi by 6. We can write the coordinate approximation as f of x equal to, as I have written before. So f of x naught plus x minus x naught delta of f of x naught whole transpose and half of x minus x naught Hessian matrix of x naught into x minus x naught whole transpose. So as we are coming to the multivariate thing, so in case of f, when we're taking f double s x, instead of f double s x, we will have the Hessian matrix. Okay, so these are the three terms in this here. One is f of x naught, the linear term. This is the x minus x naught delta of f of x naught, and the third is the quadratic term. This is the third term. This is a half of x minus x naught, Hessian matrix of x naught into x minus x naught whole transpose. So these are the notations that are used. This f x of xy is equal to del f by del x. F y of xy is equal to del f by del y. F xx of the xy is del square f by del x square. F yy of xy is del square f by del y square. And f xy of xy is del square f by del x del y. So let us see the first one. The value of f of x of xy, that is, we have to find del f by del x. So this is the first derivative. That is the first derivative with respect to x. At the point is given already pi by 3 and pi by 6. So let us see del f by del x. So del f by del x is equals to cos x into cos y. So now what at what points are given? X equals to pi by 3, y is equals to pi by 6. Okay. So if you are taking, so it is cos pi by 3 into cos pi by 6. So cos 60 is half, and cos 30 is root 3 by 2. So it is equal to root 3 by 4. Okay, simple mathematics only, there's nothing much. Okay, then the second question is we have to find fy of xy, that is del f by del y. So this is equal to del y into sin x into cos y. So difference of cos y is equal to minus of sin y. So sin x into minus of sin y. So sin 60 is root 3 by 2 and sin 30 is half, is minus of root 3 by. So the correct answer is minus of sin x sin y, and the answer is minus of root 3 by 4. Okay. Now the value of f xx of xy and f xx of f pi by 3 and pi by 6. So now we have to find the double derivative, that is del square f by del x square. So how do we do? Is equal to del by del x into del f by del x. Del by del x into del f by del x is how much? We got del f by del x is this one, cos x into cos y. So if we take the derivative, it will be minus of sin x into cos y. So it will be minus of sin pi by 3 into cos pi by 6, minus of root 3 by 2 into root 3 by 2 equals to minus of 3 by. So it's minus sin x of cos, sorry, minus sin x of cos y, it is minus 3 by 4. Next is f of, got f of xx, next is f of xy of. So what is f of xy? F of xy is del square f by del x del y. So you can also write is del y del x into del f by del y. Del f by del y is how much? This is the, this is, yeah, del f by del y, minus of sin x into sin y. So just minus of differentiation of sin x is cos x into minus of cos x into sin y. So into minus cos of cos 60, it is equal to minus of cos pi by 3, minus of half into half, it will be minus 1 by. So minus sin y into cos x is minus 1 by 4. And the last term is the f of y of xy. F of y of xy is equal to what? Del square f by del y square. So it's del by del y into del f by del y. Equal to del by del y. Del f by del y is how much? Minus of sin x into sin y. Equal to minus of sin x into cos y. Minus of sin pi by 3 into cos of pi by 6. Sin pi by 3, sin 60 is 3 by 2, cos minus 3 by 4. So the answer is minus sin x cos y. So minus sin x cos y minus 3 by. the value of the constant term f of x naught, f of x naught you can directly equal sin x into cos y. So this is again root 3 by 2 into root 3 by 2 is equal to 3y. This is the constant term. Now which of the following is the linear term? The linear term is given by what? This is the linear term. Linear term is x minus x naught into del of f of x naught whole transpose. Okay. So it is not x minus x naught means what? It is x minus pi by 3, y minus pi by 6, and del f by del x. Okay. So it is x minus 3, y minus pi by 6. Del f by del x is how much did you get? Del f by del x is root 3 by 4. And del f by del y is also minus root 3 by 4. So del f by del x is root 3 by 4. Del f by del y is minus root 3 by 4. So this is the term. So answer is x minus pi by 3, y minus pi by 6, root 3 by 4, minus root 3 by. And finally, the quadratic term. So quadratic term is how what? X minus x naught into h of x into x minus x naught whole transpose. Right? So x minus x naught is how much? X minus pi by 3, y minus pi by 6. Now h of x is del square f by del x square, del square f by del x del y, del square f by del x del y, del square f by del y square, and the last term is x minus pi by 3, y minus pi by 6. So this first and last term will be constant. Oh yeah, into half. Don't forget the half. So it will be just replace the Hessian matrix. Del square f by del x square is minus 3 by 4. We calculated before. Del square f by del x, del x del minus 1 by 4. This will be minus 1 by 4. So also minus 3 by. And the final term is minus 5 by 3. Okay, done. This is the coordinate term, so we got this. So any doubts in this? If you have, you can ask me now. Yeah, obviously answer. Okay, we will do one problem of Lagrange multipliers. The problem is uh, f of xy is given as x plus y. And g of xy is 1 minus x square minus y square is equals to 0. Now what we have to do? We have to find the optimal solutions. Solutions and classify the optimal solutions. Okay. Okay. Let us solve using Lagrange multipliers. So we can write the Lagrangian as plus lambda into g of x comma y. So it will be what? X plus y plus lambda into 1 minus x square minus y square. Okay. So we'll take the derivative with respect to the three variables. That is first is del L by del x. We'll get 1. There from here we'll get 1, and from this term will be minus of 2 lambda x equals to 0. And second is del L by del y is equals to 1 minus 2 lambda y is equals to 0, and third is del L by del lambda is equals to x square plus y square is equals to 1. Okay. So from here we can say x is equals to 1 by 2 lambda, y is equals to 1 by 2 lambda. Substitute x and y here. We'll get 1 by 2 lambda whole square plus 1 by 2 lambda whole square is equals to 1. So it will be what? 2 by 4 lambda square is equal to 1. Lambda square is equals to half. This implies lambda is equal to plus minus 1 by. Now there are two values of lambda that are possible. One is lambda is positive, and second is lambda is negative. Okay, we will see for each value of lambda. So now for the first condition, lambda is equals to 1 by root 2. So in that case, x is equals to how much? 1 by 2 root 2. Y is equals to 1 by. So the function value will be 1 by 2 root 2 plus 1 by. Now classify if this is a maxima or a minima. How do we do that? We will take the double derivative of the function and we will check at this uh, x and y what is the at these particular points if the uh, maxima or minima is there. So now f double dash of xy is how much? We have f of, so it is x1y, so it will be having, will have the Hessian matrix of del del square f by del and del square f by del y square. We are taking a Hessian matrix because it's a multivariate function. So del square f by del x square, it will be 0. F of xy is x plus y. F of xy is x plus y. If we take a double derivative with respect to x, it will be 0. This is also 0. This is also 0. This is also 0. So we cannot directly say it's a maxima or a minima. So it might be a inflection point also. So based on the value of f of xy only, we can assume it's a maxima or a minima. So now the second condition is lambda is equal to minus 1 by root 2. In this case, x is equal to minus 1 by 2 root 2. Y is equal to. Okay, I will come to that. 1 second. I'll just solve this and come to that. Minus 1 by 2 root 2 and f of xy is equals to minus 1 by. So this will be a minimum. Okay, because this is negative and this is okay. This question, sorry, the answer is not C. So answer can't be C because this in C, this you can see the transpose option here, right? So if you write this transpose, it should be in this format. It will be like x minus pi by 3, y minus pi by 6 whole transpose. If you write this as a this transpose, then after that only it comes in this format. So the correct answer is A. Okay. See, x minus x naught is this one, right? And if you write x minus x naught whole transpose, it will come is it will be the matrix will be what the rows will be becoming the columns. So it will be in this format. This is only x minus x naught whole transpose. So in C there is a transpose here. So you have to see the options carefully. Okay, so that's why the correct answer is A. Understood? Okay, if there are any other doubts, you can ask me.
So in the last problem, the value is minus means minimum means actually points will be maximum, sir. The function value is negative.
No, this is the function value, not the derivative. This is the function
Okay.
value is negative, not the derivative. Got it? Derivative will be 0. This is the function value at that at these values at
Okay.
x
Okay.
equal element. So at function value is negative, so this is a minima. We cannot directly classify here with respect to Hessian matrix because we also have because the it comes as 0 and 0 all the terms. I think there is one more thing here. Just a second, okay. I think we have to include. Do we have to include lambda also here or? In the meantime, you have any if you have any other doubts from the previous assignment, you can or anything you can ask me. The Kantakar conditions I will be going in the next class only because when we'll be talking about the inequality conditions.
Sir, good evening, sir.
Yeah.
But SAR is also not covering concatenator conditions, sir, in the online classes.
Okay.
But in assignment 5, one question is given, sir. Solve the following non-linear programming problem using concatenator conditions.
So it is given in this the week 5 or week 6 assignment.
Week 5, sir. But syllabus is not covering in that question. How to answer?
So till when do we have a deadline for submitting the assignment?
Day after tomorrow, sir.
Okay.
That
Uh,
is, but syllabus is not covered for that question in the class also.
hmm, hmm, hmm.
Yes, sir. That is the problem.
So it is the question is only equality constraint or it has like inequality constraint also.
I think inequality.
Inequality is there.
Yes, sir. Z is equal to 2x minus x square plus y is given, sir.
Huh.
Subjected to conditions are x plus 2y less than or equal to 10, x minus 3y less than or equal to 10, and x comma y greater than or equal to 0. Find the z max value.
Okay. Thing is that this will come in the next week class only. Actually, in week 6, we are covering the inequality constraints.
Okay, sir. But given in the assignment 5 question,
Uh,
that model is cover also or professor, sir, in the online classes.
hmm, hmm, hmm. Like week 6, this is live, right? You are getting video lectures of week 6 are live, or it is still not uploaded in the portal?
It's live, sir, live.
Like, so I think then you can go through a lecture of week 6 once. I think in week 6 he is teaching these conditions.
Non-linear programming.
Yeah.
Okay.
Inequality
Okay.
constant is covered in the first lecture of week 6. Constant of
Yes, sir.
lecture 14. Just go
Okay.
through that. He taught the Kantakar conditions in that.
Okay, sir.
Okay. I think there's a mistake while setting the problem. Because I didn't set the assignment. Assignments are set by someone else. So by
Okay.
mistake they have given this question in the inequality part, equality part. It's okay.
Okay.
It's no problem. You just go to lecture 14. In lecture 14, he has covered this Kantakar conditions.
Okay, sir.
Okay. Yeah. Because like to cover Kandakar, I have to explain a lot of things before, so it will take a lot of time. So that's why you need to have some basis. After that, I can explain that, yeah, details in next class. Okay, and if you don't have any other doubt, you can then maybe close today's session. Okay, then bye bye. Take care.